Hi everybody and welcome back to Chee-Tash. My name is Chris and today we're going to just keep talking through this example that I brought up last time, my store example, where we talked about some of the main principles from the book Clean Code, or started to talk a little bit about the main principles of Clean Code and put it together in a live coding example. One thing I wanted to talk about today, and we're going to try to make this a short video. Hopefully my audio comes across very clear. I'm not using my usual Audio Technica microphone, but I'm using my headset, so hopefully this records pretty good. There's no static, and that way it's a little more of a better audio quality for you guys. One of the things I wanted to talk about today was using interfaces to not repeat yourself and to make your code more modular. Some things that we've talked about in earlier episodes of Clean Code. And I wanted to do this with our store example and introduce the interface when we talk about employees. So if I go back to my store, if you guys remember from my store class, I have a list of full-time employees and part-time employees. Now these two types of employees, if I click into, let's say, the full-time employee, these both inherit from the employee class, which you guys can see here, which is an abstract class. So we're not going to be able to instantiate just a regular employee. We're going to have to funnel employee creation into either these two buckets. That's basically what I wanted to do here with abstract. So this means that I can't create a new employee, but I can create new part-time employees and I can create new full-time employees. And we're going to inherit the instance variables from employee. Okay, cool. This is also going to implement here employee pay and hours. So this is my interface that we're going to kind of talk about. If I go to that interface here, you can see some comments. Again, comments aren't completely necessary in a lot of cases. This is just here for you and I to kind of have like a little PowerPoint here. You know how last time in the last video I didn't do a PowerPoint, so consider this like a mini PowerPoint here on the advantages and disadvantages of interfaces, and there's many more advantages and more disadvantages, but I think these are kind of the main bullet points here. So this interface is going to get implemented by the part-time and the full-time employees, contains a couple methods here, right? A couple methods. So it contains calculate pay and then get weekly hours, so that both full-time and part-time employees, and you can kind of see that I kind of did that here, where you can see the use of this override annotation, which means that it's overriding the get weekly hours method from the employee pay and hours interface. And it's going to provide its own implementation for it. So this is our interface, and we're going to look at one problem here just off the bat with this interface, with this calculate pay. First off, the public method here, it's going to probably tell me that this is not needed. Modifier public is redundant for interface methods, right? So we can remove this, right? Because all methods in the interface are going to be public, so using the public keyword, we don't necessarily need it there. So we could kind of clean it up a bit, right? But this calculate pay, which I'm trying to implement in full-time employee, this won't work. This won't work unless we make a change to the interface. And this provides one of the disadvantages of the interface. And we'll talk about that list of advantages and disadvantages in a second. But here, I want calculate pay just to give me the salary of the full-time employee, which is just the instance variable. So this is literally kind of just a getter. But it's kind of hiding that information in a way. It's not exactly signifying that you're going to get the pay or get the salary. We want to calculate the pay, and hey, we don't want anybody to look at how this is done. I think maybe, can we even make this private? I don't know if we can. Method does not override. Okay, I'm going to leave that as private for now. And let's see if we can make that private. Keep that private. So The calculate pay here is just going to get the straight salary. We don't have any arguments here, right? But the calculate pay from the interface does have arguments. So what we would need to do is that we would need to have another calculate pay here. Calculate pay, and we would just do it like this, where it's not taking any arguments. So if we go back to full-time employee, okay, well that gets rid of the override in saying that, okay, we're overriding the non-argument calculate pay. But private here is an issue because calculate pay clashes with calculate pay and employee pay and hours. Attempting to assign weaker access privileges as private was public. So here, this has to be public. And that way IntelliJ lights this up, letting you know that, okay, this is being finally utilized. Usually when it's like dark like this is meaning that's, oh, it's never used somewhere. And I guess this technically this is not used anywhere yet, but you are in fact now overriding the correct a method from the interface, right? But this is a potential disadvantage of an interface because whenever there's changes to the actual interface here, then you have to make changes to all the classes that implement the interface. And you can see here, yeah, I mean, we got rid of the red for this calculate pay, but an interface is a contract. An interface is going to mean that you have to provide implementations for all the methods in this interface. So before, we were okay. Before, let's say we don't have this method, we just have this calculate pay. Okay, great. We're going to take in an int, or excuse me, a double. Okay, so let's say, yeah, just a double hourly, and then what was the other one? Int hours. Int hours, right? So this is correctly implementing this method on line 17, right? Right? But here's the thing, it doesn't really work for our full-time employee. For our part-time employee, if I come over here, for our part-time employee, I think that this would work because we could provide the implementation here that says, okay, your hourly pay times your hours, this is going to be calculating your pay. And this is even, not necessarily implementing everything. Okay, so once we implement the get weekly hours, okay, this dot hour, this dot name, employee ID, pay, okay. We would need to probably have some sort of hours here, I'm guessing, implementing, okay, and extends employee is kind of how we would want to do that. So then when I come here, I could say super dot get weekly hours. This is going to go to the super class. Yep. Okay, that's what I wanted. Let me go back to the part-time employee. Okay. So now this is working. We're not seeing any red up here. It's implementing all the methods from our interface, right? But this implementation, or this iteration, I guess implementation, yeah, of calculate pay, this instance of calculate pay with these two arguments is really good for the part-time employee because we're going to have to multiply hours hourly times their hours. And I know what you guys are saying. We could easily probably clean this up and make this a little bit more significant. Hourly, we would probably here say hourly pay, and we would here say hours worked in a day to make this a little bit more specific. So hourly pay, or maybe even pay per hour, and then hours per, let's say day, hours per day. So now pay per hour times the hours per day, right? So you make $8 an hour, you worked 8 hours in a day, 64 bucks, right? This would probably be a little more meaningful names, so just to clean it up a little bit. And in fact, I mean, we should probably even clean this up a bit in our calculate pay method. But let's not talk about that for a second here. Let's talk about the fact that full-time employee, we're just taking the salary, right? Salary. They're going to be paid a straight salary. They're not getting paid hourly. So these arguments aren't really needed. So you could say, okay, well, you could still use this method, right? But whenever you use it, you're going to have to pass in two arguments. Now, granted, these two arguments aren't going to be used, but you still need to pass them in. So this is a full-time employee. Let's say if I come over here to my store, right? And let's create a full-time employee named Chris. And he's going to be a new full-time employee, right? What kind of retirement country name? And then I have a default constructor. Okay, that's okay. If I come back to my store, Chris.set salary of, let's say it's 30K, right? And then let's say Chris.set name. Will actually call myself Chris. Right, so when I call, if I want to system.out.print Chris.get weekly hours, come here, get weekly hours. I want to say calculate pay though. Oh, my fault. If I do this, right, calculate pay. Because I'm just going to get the salary, right? I would have to pass in here, 50, just two random numbers, right? 50 and 50. Let's run this. And this should print out 30, right? And it does. 30. Let's not worry about the decimal points here and the rounding and stuff. But okay, it's printing out 30. But did you guys see that I have to pass in numbers here that don't really make a difference? Right? That aren't really needed, and they could potentially confuse a user or maybe another developer on, hey, this is a full-time employee. Why do we got to pass in the hourly rate and the hours worked, right? So this is a potential, all that to say, and I might be rambling here, but all that to say, this is a potential disadvantage of an interface where now, okay, I want to implement a calculate pay that takes no arguments, right? But this is added new. This is added after the fact, which means that all the classes that now implement employee pay and hours are going to have to change. And you should see errors, right? You should now see an error here. It's going to tell me, I don't know if you guys can read that, part-time employee must either be declared abstract or implement abstract method calculate pay in employee pay and hours. The full-time employee is going to say the same thing. You got to either declare full-time employee abstract or you need to implement the calculate pay method. So we run into this issue. Let me see, over implement method. So if I implement a method here, calculate pay, right? I want this calculate pay to show the salary, right? And then the part-time employee, you guys are going to see an opposite effect here. This dot pay times 40, let's say something like that. So now we just implemented calculate pay, but we had to change two classes for that. And this is a potential downside of interfaces, is when you change an interface, all the other classes that implement it have to change with it. If I change these arguments, full-time employee, part-time employee have to change. If I add a new method here, full-time employee, part-time employee have to change. And it has an advantage of reducing coupling and making stuff more modular, but in a way, if you're not careful, it can make things more tightly coupled. Because now I'm seeing a potential issue here, guys. I'm seeing a potential issue here in that we've got two different payment methods, and we have one that's specific for part-time employees. We have one that's specific for full-time employees. And we have to implement them because we're accepting that contract. We are implementing employee pay and hours. We have to override those three methods. But we see here that one of the calculate pays makes sense for the full-time employee. The other one doesn't. For the part-time employee, we see that one of them makes sense. The other one kind of doesn't. So, and even here, guys, I would even probably change this. I would say this dot pay. And then I would probably even do private int hours worked, right? And then I would actually probably do this dot this dot hours worked to make this work. So maybe this would actually work maybe a little bit better. And I can actually, here, I'll do this. This might be actually a little bit better. So maybe we wouldn't even need this pay per hours, and maybe we could just get rid of this. So yeah, I think actually we could probably, if I go back to this interface, I'm just going to get rid of this. I'm just going to get rid of that. We'll get rid of this. We'll get rid of it in the part-time employee. Kind of cleaned it up a little bit. Come back to my store. Now when I run this print statement on line 36 should be able to print off 30,000, which is the salary of Chris because he's a full-time employee, and it does. You guys can see that down there. Hopefully you guys can see. I don't have to maximize this too much, but you can see how it's potentially tightly coupled. That's one disadvantage of it. And the other disadvantage is, that these are public methods. These are methods that you can't make private. So people are going to have access to these methods, which is overall probably a good thing. And you can hide the data or hide the instance variables or whatever data in your classes that you want, and only illustrate the data that you want to your customers or the users or what have you through these public methods. So maybe that's not entirely a huge disadvantage, but just to be aware of it, you want to be careful what you display with calculate pay, right? What if you add to the interface? We talked about this one. If you add methods to this, you have to then change all these other classes, and it could potentially lead to a lot of overhead. And then coupling of the interface's definition for a method, coupling to the interface's definition for a method. So we saw that with the calculate pay. Now, we cleaned it up a little bit here, but we had a definition of calculate pay that took in 2 arguments. Now, we have to implement that method with 2 arguments in all the classes that implement this interface. Because we did that before with the full-time employee, where we had a calculate pay with 2 arguments right here on line 28. But we didn't need those 2 arguments. But that's the way the contract is set up. We had to set it up like that. And it might lead to confusion because we weren't even using those 2 arguments. We were just returning straight up the salary from the instance variable of full-time employee. So some things to kind of keep in the back of your mind when using interfaces. Now, that doesn't mean that they're all disadvantages. There's lots of advantages to interfaces. It provides a level of abstraction. It provides a more modular code base because now it provides for some reusability in that you can now customize the way you calculate pay. Now, whenever you want to maybe make a change, you can just make it in one spot in your employee pay and employee pay and hours interface. You can just make the change up here, and you don't have to make the change in every single class. Although I know it kind of sounds like I contradicting myself there because yes, if you add to this method, you got to change it in all the other classes, right? But maybe sometimes that doesn't provide so much overhead. In other instances, if you make a change in employee pay and hours, 50 classes are implementing it, then yeah, maybe it is a ton of overhead. So just to be mindful of that. But you can decouple from concrete implementations. So you don't have to provide a specific calculate pay method for full-time employee, a specific calculate pay method for part-time employee, and you can just implement it from employee pay and hours, right? And you don't have to provide these concrete implementations. You can just use the override keyword. And that way it makes your code maybe a little bit more modular. Two big things that we talked about from clean code were dry, which was don't repeat yourself, and SRP, which is the single responsibility principle, which means your classes should only have one reason to change. Only one reason to change. So just some stuff to think about, guys. I wanted to make this really short. We're at 20-ish minutes right now. That's all I'm going to say for now. Just wanted to keep building off of this My Store example, and hopefully you got something out of what an interface is, what it does, how you can use it to your advantage, and also kind of watching out for some things that could cause issues down the line when your code base gets larger and more complex, and that interfaces aren't a entirely going to like solve your problems and make your code base better. They definitely can, but there's ways in which they can actually make your code maybe a little more complex. So that's going to do it for today, guys. Thank you very much for listening. We'll be back next week. Maybe next week I actually might continue on with the next chapter of clean code. I think the next chapter was JUnit, and then there's a chapter after that. The JUnit one is just more coding examples, not really anything even to do with JUnit testing from what I saw. So maybe we'll just move ahead with the next chapter. I'll have to take a look and see what that involves. But the code, the book is actually, we're almost done with the book. So thank you guys very much for listening. My name is Chris. This has been Chee-Tash. Take care, everybody.